Hello viewers, welcome to my channel. I'm Hasham. So far 10 problems I have completed on transportation. So every problem you will find some new points like unbalanced problem or degeneracy problem when we have to make a loop if all the opportunity costs are not positive. All these complications we have seen in the previous 10 problems. Few more problems I'm going to explain you. So if you want the perfect knowledge, watch all the videos from beginning till end. Don't skip in between. So if you have not watched, I suggest you go to the playlist of my channel, select the subject Operation Research. Select the topic of transportation problem. Be perfect about the concept. Watch all the videos, not once, twice, thrice, and maintain notes. When I explain something important, always keep a notebook, record it. Then only you can be able to get the perfect knowledge. Now in this video, I'm going to explain you problem number 11. It's a very simple problem. And before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep ready the problem, take the screenshot of the points, then I'll explain the problem in complete detail. Now see the 11th problem. A cement factory manager is considering the best way to transport cement from his three manufacturing centers P, Q and R and to depots A, B, C, D, E. So the supply of origin is the manufacturing center, that is PQR. From PQR supplying the cement. Where it is being reached, destination are the depots A, B, C, D, E. The weekly production and demand along with the transportation cost per ton are given below. So PQR, 3 rows are there and 5 columns A, B, C, D, E. Then total of the supply is 60, 35, 40. Total supply is 135. Similarly, the total demand requirement at the depots are 22, 45, 20, 18, 30. If you add up, it comes to 135. So fortunately, the problem is a balanced problem where total supply, total demand both are equal. Then what should be the distribution program? That means the company wants to find out how many units should be transported from each of the factory to each of the depots. That is the problem, right? So first of all, we find the IBFS by Vogel's approximation method. Actually, 3 methods are there. Least cost method and northwest corner rule and VAM. But the superior method is VAM. Why? Because whatever IBFS we get through VAM will be the same optimum solution, or sometimes one more table may be required. But if we follow the IBFS by northwest corner rule, then easily we can get the IBFS, but the optimum solution will be very far away. Lot of time will be required to find the optimum solution if we go through northwest corner rule or least cost. That's why this method is always preferable. Now, origin factories are PQR, destination depots are A, B, C, D, E. And I have taken all the unit cost 4, 2, 3, whatever is given in the problem. And the supply 60, 35, 40, 40, 22, 25, 20, 18, 30, 130. That's this is the complete problem given. Now I have opened row penalties and column penalties. This is the requirement as per VAM. Penalty is the difference between the smallest cost and the next smallest cost in every row and column. In the first row, you can see the minimum is 1. Next minimum is 3. So 3 minus 1 is 2. Minimum is 3. Next minimum, minimum is 1. Next minimum is 3. So 3 minus 1, 2. Here the minimum is 2. Next minimum also 2. So 2 minus 2, 0. Here minimum is 2. Next minimum 3. So 3 minus 2, 1 over. Row penalty completed. Column penalty. Minimum is 2. Next minimum 3. 3 minus 2, 1. Here minimum 1. Next minimum 3. 3 minus 1, 2. Here minimum 2. Next minimum 2, 0. 2. Next minimum 4. So 4 minus 2, 2. Minimum 3. Next minimum 4. Difference is 1. That's it. We have calculated the penalty for row and column. Now find out the highest penalty. 201 1, 2, 0, 2, 1. Highest is 2, but there is a tie. 3 times 2 is coming. So we have to find out where the cost is less. If there is a tie in penalty, we compare the cost. Wherever we have lower cost, that is preferable. If we select this 2, the lowest cost is 1. If we select this 2, the lowest cost is 2. If we select this 2, the lowest cost is 1. So even with whether we select this 2 or this 2, we are coming to this cell only. So select anyone. Suppose I have selected this 2. Then what will happen? This 1. So how much allocations I can give here? Row total 60, column total 45. So 45 allocations I can give. 45 minus 45, 0. So 60 minus 45, 15. This column is blocked. That's all. The first penalty completed. Now second penalty. Minimum is 3. Next minimum 4. So 4 minus 3, 1. Minimum 2. Next minimum 2, 0. Minimum 2. Next minimum 3. 3 minus 2, 1. Column wise. 2 to 3, 1. This is dash. Completely column is blocked. So dash. Here 2 minus 2, 0. Here 2 minus 4. 4 minus 2 is 2. Here 4 minus 3 is 1. So in the second penalty you can see 1, 0, 1, 1, 2, 0, dash 1. Highest is 2. So select. Only once it is coming. So 2. In which column? D column. Minimum cost is 2. In this column minimum cost is 2. Row total 35, column total 18. So 18 is the minimum. So 18 we allot. 18 minus 18, 0. 35 minus 18, it is 17 I think. 35 minus 18, it comes to 17. So here 17 remains. So this column has become 0. So I block the column. That's all. 2 penalties I have completed. Now I am coming to the third penalty. Third penalty. So here minimum 3, next minimum 4. So 1. Here minimum 2, next minimum 2, 0. Minimum 2, next minimum 3, 3 minus 2, 1. Here 3 to 2, 1, dash. Then here 2 to 0. Here dash. Here 3, 4, 1. That's all. So third penalty what we are having? 1, 0, 1, 1 dash 0 dash 1. So 1 is occurring 4 times. There's a tie in 1. So we compare the cost. If we select this one, the minimum cost is 2. If we select this one, the minimum cost is 3. So we are not going to select this one, right? We are going to select this one. Again, if we select this one, the minimum cost is 2. If we select this one, the minimum cost is 3. So we are not going to select this one and we are not going to select this one. Now these two we will consider, this one and this one. Because if we select this one, the minimum cost is 3. If we select this one, the minimum cost is 2 here. If we select this one, minimum cost is 2. If we select this one, minimum cost is 2. The cost is time. So we compare the allocations. Wherever we can give more allocation, that will select. If we select this one, the allocations which can give row 17, column is 22. So 17 allocations we can give. If we select this one. If we select this one, this two, how much allocations? Row total 40, column total 20. So here if we select 17 allocations, here if we select 20 allocations, so we select the 20 allocations. So select this one, this two. So row total 40, column total 20. So we allocate 20 units. This will become 0. 40 minus 20 remains 20. So which is blocked? The column is blocked. The column is 0. So this column I am going to block it. Finished. 3 penalties completed. Now I am coming to the fourth penalty. 4 minus 4, 0. Here it is 3. 2 to 3, that is 1. Here 3 to 4, 1. Now column wise, 2 to 3, 1. Here dash, dash, dash. Then 3 to 4, 1. Again we are having 1, 1, 1, 1. So there is a tie in the penalties. We compare the cost. If we select this one, the minimum cost is 2. If we select this one, minimum cost is 3. So we are not going to select this one. If we select this one, again minimum cost is 3. We are not going to select this one. If we select this one, the minimum cost is 2. So whether we select this one, 2 rupees, or this one also 2 rupees, to select any one, this I am selecting, right? So how much allocations I can give here? Row total 17, column total 22. So 17 allocations I can give. 17 minus 17, 0. 22 minus 17 is 5. So here row is blocked. That's it. Now still one more penalty we require, because two unoccupied cells first row and 2 unoccupied cells third row. 2 unoccupied cell first column, 2 unoccupied cells last column. Again, one more penalty we require. Last one, 4, 4, 0. Here dash. Here 3, 2, 4, 1. Here 4, 3, 1. Then dash, dash, dash. 4, 4, 0. Again, we are getting 1 and 1. There is a time penalty. Compare the cost. If we select this one, minimum cost is 3. If we select this one, again we are coming to this only. So we select this one. So how much allocations we can give here? Row total 20, column total 5. So I'll allocate 5 here. So 5 minus 5, 0. 20 minus 5 is 15. So here 0. So column is blocked. That's it. So I have completed 5 penalties. Now if any row or column, a single unoccupied cell is there, then we take the balancing figure. In the first row you can see only one unoccupied cell. Only one, and the row total is 15. So I will make 15 here. This will become 0. 30 minus 15 remains 15. Now last and final one unoccupied cell is left. The row total 15, column total 15. So here I am allocating 15, 0, 0. That's all. Now you can see all the cells are either occupied or blocked. No blank cell is there. And all the supply and demand becomes 0. 0, 0, 0. Here also all zeros. That means correctly we have made the allocations according to VAM method. IBFS according to VAM. Now the next step is number of allocations must be equal to m plus n minus 1. How many allocations? 1, 2, 3, 4, 5, 6, 7. The number of allocations are 7. M plus n minus 1. M stands for number of rows, n stands for number of columns. 3 rows, 5 columns. So 3 plus 5 minus 1, that is equal to 7. That means fortunately our number of allocations are equal to m plus n minus 1. So this IBFS is feasible or non-degenerate. Now it's a green light. We can go ahead in calculating the optimality test by UI and VJ method. Same table, the same table without penalties. Without penalties, the same table we have to draw. Origin PQR, destination A, B, C, D, E. All the costs, whatever we have taken here, 4, 2, 3, 1, 3, 5, the same 4, 2, 3, 1, 3, 5 we have taken. The demand, same demand, 22, 45, 20, and supply 60, 35, 40 total. Apart from that, one extra row and extra column for UI and VJ. So here VJ, V1, V2, V3, V4, V5, and U1, U2, U3, right? We have taken. Now we take the allocations from IBFS. The allocations are 45. So I am writing 45 here. Then second 15. Here I am taking 15. Next one 17. Here I am taking 17. Then 18 to 18 is here. Right, 18. Next one is 5. Next one is 20. Next one is 15. That's all. Now you confirm 17 plus 5, 22, 45, then 20, this 18, 15 plus 15, 30. Row wise, 45 plus 15, 60, 17 plus 18, 35, 5 plus 20 plus 15, 40. That means correctly we have taken, right? Now we need to find out the ui and vj values. u1, u2, u3 and v1, v2, v3, v4, v5. So totally values. We have to take arbitrarily any one of the u value as 0. Either you take u1 or u2 or u3. So arbitrarily I have taken u3 is equal to 0. Then you'll get a doubt. Why, sir? Why you have taken u3 is equal to? Why can't we take u1? U1 is definitely you can take, because I want to save the time. Because 3 allocations we are having in this third row. So easily I can find out v1 value as 3, then v3 value as 2, and v5 value is 4. So without calculating, without applying the formula, I got the values. 3 values I got it ready-made. Even if we apply in the formula, we'll get the same thing. How? I'll show you. Let us take u3 is equal to 0. The other values of ui and vj can be found by using the following equation. Cij is equal to ui plus vj for occupied cells. The first occupied cell is this one I will take. So 1, 2. First of all, this one. For this one, 3, 1. So C31 is equal to U3 plus V1. How much is C31? Here you can say C31 is 3. 3 is equal to U3. U3 I have taken it as 0 plus V1. So 3 is equal to 0 plus V1, or simply we can say V1 is equal to 3. Already I got it. So even without writing this, we will get it. Similarly this one, 3, 3. C33 is equal to U3 plus V3. So C33 how much here? 2. 2 is equal to 0. U3 is 0 plus V3. So V3 is equal to 2. I got V3 is equal to 2. Lastly, 3, 5. C35 is equal to U3 plus V5. How much is C35 here? 4. 4 is equal to 0 plus V5. So we can say V5 is equal to 4. We got it. V5 is equal to 4. So that is the advantage, that if I take the U3 is equal to 0, because we have 3 allocations, directly we got it. Now I'll move on to this one, 2, 1. C1, 5. Okay, C1, 5. C1, 5 means this one. C1, 5 is equal to U1 plus V5. How much is C1, 5 here? 4 is equal to U1 we don't have, plus V5 already we have 4. So U1 is equal to, this 4 you bring it to LHS, so 4 minus 4 will become 0. So U1 is equal to 0. We got this value, right? Now C12, this one. By using this occupied cell, we can be able to get the V2 value. C12 is equal to U1 plus V2. How much is C12? 1. 1 is equal to U1. U1 is 0 plus V2. So we can say V2 is equal to 1. 1 is equal to 0 plus V2, or simply V2 is equal to 1. So we got V2 value 1. Now we take 2, 1, this one. By using this cell, we can be able to get the U2 value. What is the location? 2, 1. C21 is equal to U2 plus V1. How much is C21? 2. 2 is equal to U2 we don't have, plus V1. V1 we have 3. Now you can see, bring the 3 to LHS. So 2 minus 3 is equal to U2. So 2 minus 3 is minus 1. So U2 is minus 1. U2 is equal to minus 1. Right? Last one, C24. C24. This, by using this cell, we can be able to get the value of V4. So C24 is equal to U2 plus V4. What is C24 here? 2. 2 is equal to U2. How much U2 we got? Minus 1. Plus V4. So bring the minus 1 to LHS. So minus 1 will become plus 1. So 2 plus 1 is equal to 3. So V4 is equal to 3. V4 is equal to 3. That's all. We got all the values you can see here. V1, V2, V3, V4, V5, U1, U2, U3. All the values of UI. Next thing, we have to calculate the opportunity cost of unoccupied cells. The formula is delta Ij is equal to Cij minus Ui plus Vj. Either by making this note you can calculate, or directly by seeing this table also you can calculate without writing all these things directly. Because from Cij, deduct the sum of ui plus vj, add up ui and vj and deduct this from Cij. That's it. For example, the first cell, delta 11. Delta 11 is equal to C11 minus U1 plus V1. So delta 11 how much we are having? C11 how much we are having? 4. So we can write 4 minus U1 is 0 plus V1. V1 is 3. So what we can? 0 plus 3 is 3. So 4 minus 3 is 1. That's all. We got the value 1. Or else, if you don't write that one, directly I'll show you. So Cij minus ui plus vj, 3 plus 0 is 3. So 4 minus 3 is 1. Similarly here you can see 3 minus 2 plus 0. 2 plus 0 is 2. So 3 minus 2, 1. How? I'll show you. 1, 3. 1, 3. So C13 is 3. Minus U1 is 0. Plus V3 is 2. So 0 plus 2 is 2. 3 minus 2, 1. Either you calculate like this or directly you can calculate. Right? Here, 3 plus 0 is 3. 4 minus 3, 1. Right? Here, 1 minus 1, 0. So 3 minus 0 is 3. Here, 2 minus 1 is 1. So 2 minus 1 is 1. Because in bracket, 2 minus 1 is 1. So 2 minus 1 will get 1. Similarly, 4 minus 1 is 3. So 3 minus 3, 0. So here, 1 plus 0 is 1. 5 minus 1 is 4. Here, 3 plus 0 is 3. 4 minus 3, 1. That's all. We have calculated all the opportunity cost of unoccupied cell. 1, 1, 1. Here 3, 1, 0. Here 4, 1. That's it. What do you observe? All the opportunity costs are positive. When all the costs are positive, we reach the optimum solution. Whatever the allocations are there, this is the best allocation. By using this allocation, the total transportation cost will be minimum. Right? So here, since all the opportunity costs are positive, so optimum solution is reached. The optimum allocation and its total minimum transportation cost is as follows. Now find out the allocations. Allocations are P to B. First one. P to B. How many allocations? 45, 1. So 45 units, 1 rupee. Then P to E. P to E, 15 units, 4 rupees. Then Q to A. Q to A, 17 units, 2 rupees. Then Q to D. Q to D, 18 units, 2 rupees. Then R to A. R to A, 5 units, 3 rupees. Then R to C. R to C, 20 units, 2 rupees. Then R to E. R to E, 15 units, 4 rupees. That's all. So we have calculated, we have made the allocations. Now calculate the cost. 45 into 1 is 45. 15 into 4, that is equal to 60. Then 17 into 2 is 34. 34. Then 18 into 2 is 36, right? 18 into 2, 36. 15 3s are, 5 3s are 15. 20 into 2, 40. 15 into 4, 60. That's all. Now find the total. 45 plus 60 plus 34 plus 36 plus 15 plus 40 plus 60. It comes to 290. 290. That's all. So comparatively, this 11th problem is very, very simple, because directly we got, first of all, the problem is balanced problem. No need of dummy row or dummy column. It is balanced problem. Secondly, number of allocations we got is equal to m plus n minus 1, so the problem is non-degenerate, feasible, we can go ahead. So similarly, we have calculated Ci, that means U3 values of Ui and Vj values. We have calculated all Ui, Vj values. After calculating that opportunity cost, only two I have shown. Remaining directly I have shown it in the table. Why to write all these things? So Cij minus Ui plus Vj will get the opportunity cost. All the opportunity costs are positive, so we reach the optimum solution. So this is the end of problem number 11. Inshallah, we'll continue the 12th problem in the next video. So if you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed, and buy the super thanks which is given below my video. Inshallah, we'll start the 12th problem in the next video.